Our speaker today is Dr. Ibrahim Issifu. He is a postdoctoral fellow here at IOF in Peru in our group at the Fisheries Economics Research Unit. He obtained his PhD, Masters and BSc actually at Nagoya University in Japan. The PhD and the PhD in Nagoya, and his Masters and BSc at the University of Ghana in Accra, So he actually speaks some Japanese. You can try him on that if you speak Japanese. His main research interest lies in the intersection of marine plastic pollution, fisheries economics, and ocean sustainability. And while not having the power, he doesn't believe he has the power to change the status quo. I will challenge him on this when we get the time after this talk. He doesn't think he has the power to change the status quo in any of these areas. He still believes that he can at least stir the pot by conducting topical and timely research in this intervention and intersection, so that to help policy and move us forward. Issifu worked as a research assistant at the Nagoya University and as a health economist at the Baba Memorial Hospital in Osaka, Japan. He also has experience teaching microeconomics for the Faculty of Forestry here at UBC. I met Ibrahim actually when I met him personally when I went to give a talk, invited to give a talk in Tokyo, and then we chatted after the talk, told me his interest. He had just finished his PhD, started working. He would like to do research, and just at that time, I had been invited to join this plastic project, and so, I got resources to hire a postdoc because they wanted some economic analysis that I didn't have time to do myself. So that's how we got him over, and today he's going to talk to you about that large plastic project, which involved many people, and here you have some of the story from that project. That project was funded by Pew and actually led by Pew scientists. So I'll stop here and over to you, Ibrahim, and we will come back at the end of the seminar when you finish your talk.
Thank you very much, Dr. Rashid, for a very brilliant introduction. And thanks very much all the professors and colleagues who have able to make time to be able to attend this workshop. So I will just go briefly to what we are going to talk about today is about an integrated model of mitigating plastic pollution. And Rashid has already talked a little bit about it. It was headed by Pew and with Systemic in UK, including 17 core panelists for the project. And you can see Professor Richard Bailey of Oxford University, and our own Rashid. Rashid is here. Rashid is also among the 17 core panelists for that particular project. And these 17 researchers cut across academia as well as industry. We have leading thinkers in the industry or experts in industry as well as academia. And we were asked to be part of, to provide much needed economic analysis or to at least to support the research work. So this is about 17 of them, and you can see, probably you may know some of them already, apart from Rashid. We have Professor Thompson, UK, has written so much about microplastic. So let's go today to what the outline for today's presentation. So first, I will talk about the evolution of plastic production, how plastic started around 1950s and up to date, and the trajectory about plastic growth over the years. And I will also talk about ocean plastic leakage. All these plastics have been produced. Of course, plastic has served so many important. You can think of almost handling food, a lot of things. Almost everything that we do now, there's elements of plastic component in it. So, but sometimes these production activities leads to what? Ocean plastic leakage. We'll talk about that one too. Then I also talk about the impact of marine plastic pollution. after all this, and what is the impact of marine plastic pollution? We'll look at it, as well as we'll also look at scenarios and model output. That big project that Rashid just gave a summary, which comprised of 17 experts across academia and industry. We'll talk about the scenarios that we came across, we constructed, and the model output, what are the solutions or the interventions we're able to put across to mitigate at least marine plastic pollution. Good. So join with me. First, let's briefly look at evolution of plastic production. More or less, this is the background. Actually, while we are all familiar with plastic, the material is relatively novel. It wasn't until the 21st century that plastic production actually saw. So we can see that from 1950, a little, just about 2 million metric tons of plastic was produced. By 2017, we have almost about 348 million metric tons of plastic was produced. So over these 67 years, annual production of plastic increased nearly 117-fold. And if you want to put this one into context in terms of population, which means that it's equivalent mass of about 1/3 of the world population, looking at the trajectory of plastic growth. But plastic, they say, plastic comprised of so many things, like what we call plastic. It's made of different polymers. We have propylon fibers, thermoplastics, thermosets. It's a world on its own. So plastic comprised of so many things. Now let us take into the major plastic producing country. Which countries are producing plastic? So as we can see, like the chart tells us that from 2008, that actually plastic production just saw. Just before that, it wasn't that great. But from 2008, we just saw a very exponential growth for plastic. So let's now look at which countries are the top plastic producing countries, either regions or countries. Good. So first, what we have seen here is that this is plastic production by regions in 2018. And this is actually taken from Plastic Europe 2018. So we have in 2018, the total worldwide production of plastic amounted to about 360 million metric tons. And Asia alone produces about half of it. You can see China produces about 30% of world plastic production, and the rest of Asia is about 17. So when you add 17 to 30, as well as Japan, which produces about 4% of plastic production, and we have NAFTA, North American Free Trade Area or Agreement, they produce almost about 18% of plastic. Now my own continent, Africa, Middle East and Africa, we produce about 7%. But actually, I'm sure that about 4 to 6% of the production in Africa probably coming from Middle East, because they have a very large store of petroleum and gas, like hydrocarbons and plastics generally produced from those things. Good. So Africa actually produces a little amount if you look at Sub-Saharan Africa. So, but if you combine Middle East and Africa, we produce about 7% of what global plastic production. And Latin America produces about 4%. So Asia alone produces about 51% of global plastic production, or more than about half of the world plastic production. Now let's look at it in terms of per capita production. So of course, we can see that from the map, China is the world's largest producer of plastic in the world. Then followed by NAFTA, which is the second largest plastic producing region in the world after China, and accounted for 18%, I've said it. But in terms of per capita production of plastic, we can see that China is just about 77 kg per capita. But in terms of NAFTA, it's about 132 kg per capita in 2018. Japan produces only 4% of plastic. Yes, I schooled in Japan, as Rashid have said it earlier. If you go to supermarkets of Japan, you see that actually supermarkets are just like a plastic paradise in Japan. So there's a lot of plastics in Japan. The Japanese produce plastic a lot. But the good thing is that they are very good at managing plastic. When they waste, the post-consumption plastic, they're able to manage it very well. Good. So in terms of per capita of plastic production in Japan is around 107, yeah, 117 kg. Then Europe is around 11 kg per capita. Good. Then let's look at China export of plastic. China produces a lot of this plastic, also export this plastic. So China's export of plastic amounted to about 14.23 kg, almost about 15 million tons or metric tons in 2019. And the value of those exports amounted to 48 billion US dollars. China is a key producer of plastic, and China at the same time is also is like a major importer of plastic. And we'll look at all those things as we go on. So in an ideal world, all plastic that is produced, in an ideal world, all plastic that is produced should be able to be recycled or managed very well. But a significant amount of this plastic waste enter our water bodies. So let's take a look at the 10 most polluted rivers in the world. We can see that these are global polluting rivers by plastic input into ocean in 2017 in thousands of metric tons. And all figures are based on midpoint estimates. Input rates are representative of mismanaged plastic waste and catchment runoff. And you can see the stars display the average volume of river plastic mass input into oceans around the world as of 2017. And this is reported in the literature by Libreton and Ectal 2017 in our Nature Communication. So Yangtze, a very famous river in China, Yangtze River in China had an estimated annual input amounting to 333,000 metric tons of plastic. And this is also followed by the beautiful Ganges, the Ganges in India, of course, which has more religious significance and also serves as a source of livelihood for millions of people around the Ganges. So it also has an annual input of plastic around 115,000 metric tons. Then Africa is not also safe. We can see the River Cross, that's in Nigeria, between Nigeria and Cameroon. It's also annual inflow of plastic input. That river is about 40,000 metric tons of plastic. So, and Solo River in Indonesia. So these are the 10 most polluted rivers in the world, as reported by Libreton and Ectal in 2017. So as we have seen all this, how plastic is actually getting into the oceans and Asia, especially Yangtze River and ex-India, some of the big rivers you can see there here, most of them are in Asia. Is apart from Cross River, which is in Nigeria and Cameroon, we can see Philippines, Myanmar, Indonesia, China, India, and as well as, yeah, of course, Indonesia, Ecuador, which is like, yeah, which is separate. So most of these inputs that gets into plastic inputs that gets into our rivers are mostly concentrated disproportionately in Asia. So from rivers to our continental waters. So let's see, once this plastic gets into the rivers, as we have been able to see, then what happens? You know, there's always a flux. Some of these plastics are likely to move into our continental water bodies. So we are going to look at how these things move into continental bodies. So the next slide talks about plastic waste into continental waters or into our oceans. So as you can see, we have plastic input share from rivers into ocean by region in 2015. And this is also reported by Libreton and Ectal 2017. So this stars displays the share, it talks about the share of plastic input from rivers into oceans worldwide in 2015, broken down by key regions. We have Asia, Africa, South America, Central and North America, Europe, and Australia Pacific. So in that year, in 2015, we have 86% of plastic input from rivers into ocean were generated in Asia. You can see Asia alone generated about 86% of what plastic input into our rivers. And we have Africa. Of course, I was a little bit surprised, but I saw this figure, which look coming from that continent. I'm not so much worried. In my country, Ghana, we have a lot of plastic. We have problem with it. So Africa has almost about 8% of share of plastic input into our continental waters or oceans. So, but annually, it is estimated that 8 to 12 million metric tons of plastic is leaked into our oceans every year. You can look at leading publications like Jambeck et al. 2015, as well as Winnie Lau from Pew et al. 2020. Of course, we are going to talk much about the paper that she actually led from Pew. So she also said about 8 million to 12 million metric tons of plastic enter our continental waters or oceans every year. So what happens when the plastic input accumulates in our oceans? So this is something that we must all look at, because the ramification as it moves from rivers into our continental waters, it accumulates there. Of course, it's a foreign material that gets into the water. It's likely to pose some harmful effects. So we are going to take a look at what happens when plastic input accumulates in our continental waters. So impact of marine plastic pollution. So the first one is marine plastic pollution is proving deadly for marine organisms. A lot of literature has been, of course, documented about how marine plastic pollution is posing a threat to marine organisms. At least almost about 700 marine species have encountered marine debris, with at least 17 of them listed on what International Union of Conservation of Nature red list as near threatened, according to Gall and Thompson, reported in 2015. Yes, we have almost about 700 of marine species have been encountered with marine debris, and at least 17 of these species are listed on International Union of Conservation of what nature. And we have also seen that 92% of the individual encounters with marine debris are with plastic, and that over 10% of the species encountering marine debris had ingested plastic, of course, and not some of them entangled, and others who eject or swallow the plastic. Some of them mistaking the plastic as food, especially the small lower organisms mistaking it, and they swallow it. And this is reported by Gall and Thompson. So we just try to look at how some of the infographics tells about the impact of marine plastic pollution. We have a turtle. You can see a turtle being entangled in a net, a discarded kind of fishing gear. And this is reported in the Mediterranean, close to Spain. And we have our beautiful beaches. This is a very nice beach near Lebanon, or in Lebanon, which is also straddled with a lot of plastic. You can see the beach is covered with plastics all over the place. Good. So these are some of the potential impact of plastic in our marine ecosystem. So with all these things, then economics and scientists try to quantify what are some of the cost of all these things into our system. So we look at the cost. So marine plastics may also increase the concentration of persistent organic pollutant. Of course, it's a very big issue in ocean studies. Of course, marine organic persistent, or POP, persistent organic pollutant, is a very serious problem. And we are saying that, according to Rochman et al., that marine plastic pollution may also exacerbate the concentration of persistent organic pollutant in the flesh of fish and shellfish. And this may also pose an additional risk to consumers. Of course, some of us would, a lot of people depends on the seafood, or mostly people, a lot of people eat seafood. So as this thing gets, it may exhibit the concentration of persistent organic pollutant, and some of them like organic pollutant, we have mercury, we also have dioxin, a lot of them. So all these things can also exacerbate that. And when it gets into the flesh of fish and shellfish, what we cherish so much, it may pose additional risks to consumers. So next, we look at the cost of it, all these things. So we economics and researchers try to put the cost and see how much this thing is costing us. So the economic cost of marine plastic pollution can range from $33,300 to $33,000 per ton per year in terms of reduced marine natural capital, according to Botman et al. So we have also, it has a very devastating impact in tourism, and especially coastal population, people who live along the coast, or we have a large number of people along the coast. So it also poses a very big problem to them, as well as a multitude of ecosystems that depend on the ocean in one way or the other. So marine plastic pollution is a very huge threat to our marine environment. So now we'll look at the project, the big project. This is just the background to the project that we did, with led by Winnie Lau of Pew, about 17 panelists. So first, I'll talk about what the project has been able to cover and what it has, which other part that was not covered as far as the analysis is concerned. So you can see that the green shaded portion in the boxes tells us that this is the scope of the project. This area were in scope. This is the area that the project were able to cover, or in scope. So we have plastic packaging and single-use products. Of course, we also have diapers and sanitary waste. We have cigarettes and consumer durables. All these things, and they constitute about 95 to 99% of leakage. So the project was able to cover that. But the one in the red, like slightly red, was not covered by the project, like medicals, electronics, textiles, and other transportation things. Of course, most of transportation and constructions are thermosets. So the project did not cover much about that. So microplastic, the project also covered from the macroplastics, we also covered the microplastic. And 75 to 85% of microplastic leakage is with tire abrasion, textiles, losses, plastic pellets, and as well as personal care products. So these four thematic areas were covered under microplastic. Areas like building paint, road paint, industrial abrasion, agricultural, plastic waste, etc., were not covered by the project. So as well as we're talking about marine oceans, of course, we have to look at maritime sources of plastic pollution as well. So fishing gear and shipping losses, of course, which constitute about 95 to 99% of maritime leakage, were also covered by the project. So the red one is out of scope, and in the scope is the green. So now we go to the main map of the project, because the project came up with what we call a global system map. After we're able to know the scope of it, so we move to what we call the global plastic system map. It's a system map because different units of plastic value chain were put together. So let's look at the first part. And this global plastic system map is a stock and flow kind of analysis. It was modeled the stock and flow, and it's divided into 5 units. We have production and consumption. Of course, we have demand for plastic utility. We have plastic reduction, and I'll move a little bit faster. We have collection and sorting, where transport, like plastic trade, import and export, falls under collection and sorting. We have formal collection, informal collection, mixed collection, etc. Then the next one is recycling. So we look at recycling, and we have closed loop recycling, open loop recycling, and chemical conversion to monomers and hydrocarbons. And when we talk about closed loop mechanical recycle, I'm sure most of us are aware or understand what it means. Closed loop mechanical mechanical closed loop recycling is basically about designing a plastic product or a product with recycling in mind. So this particular one doesn't leak into the system, and Dell is noted for that. So for example, aluminum can can be recycled into a different form of cans and with little waste creation. So it falls under closed loop mechanical recycling. We have open loop mechanical recycling. Of course, this one is recycling into a new product, something like a pen, like you take plastic water bottles and recycle into pens or sleeping bags. They fall under open loop mechanical recycle, and they have the tendency of leaking into our marine environment. And the next one is disposal. So disposal, we covered about engineered landfills. We also covered about thermal treatment with energy recovery, as well as fuel fraction from chemical conversion. So this is the fourth component of our global plastic system map. And the last one is what we call mismanaged. So the mismanaged part, that is where you can see it in red, where we have the ocean leakage. So what this thing is telling us that the system map is telling that from production and consumption, it's possible that plastic can leak into the oceans, and also from our collection and like trading activities, like collection and sorting activities, where formal collection and informal collection can also lead to what dump site, and which can finally get into our oceans, as well as disposals, if they are not well disposed, can also get into our ocean system. So this is the global system map. But I will take a little bit more of your time to explain this map because it's the engine of the whole analysis. Most of, I've said it earlier, it's a stock and flow analysis. And the data, plus waste data is notoriously very hard to get, but we did our best to get the data across the world. And sometimes where data is lacking, we're able to purchase proprietary data and also conducted intensive expert level interview to get their opinion. Good. But in terms of once it is stock and flow, so it means I'll talk a little bit about the methods. So the stock, you see that where there's those dash box. So the dash box just talk about that is first, the boxes tells us that is the accumulation point. That is where there's letter boxes represent mass aggregation point in the model. Whilst the arrows represent mass flow. So the arrows tells us the flow. That's what I've said, it's a stock and flow analysis. And boxes outlined in dashed lines represent places where plastic mass leaves the system. Example, you look at open loop mechanical recycling. So you can see the dashboard, that's an area that it can leak into the system. And you can also see dump site, and as well as terrestrial dumping and open burning. They are potential areas that plastic leaks into the system. In terms of methodology, yes, the methods that we use is we use ordinary differential equation models to model the stock and flow, as well as 5 different interventions. And data, as I've said, data is not easy to come by because data in waste management is a very serious issue. So there's a lot of uncertainties as far as the data is concerned. So the uncertainties was propagated through the model using multi-color simulations. And the model was also validated using sensitivity analysis. So I'll now, oops. So we'll move to, I'm sorry for that glitch. So we go to geographical differences, how the system map was modeled. So we made so many assumptions, and some of the assumptions, I'll just skip them. And first, it's a global study. So we have geographical differences were accounted for plastic via what we call 8 archetypes. And these archetypes are like the whole world is divided into 8 archetypes. We have based on, because plastic generation is a function of population, also a function of income with other variables. So first, in terms of population and income, we divided the whole world into high income, and within every high income is split into urban and rural area. So you can see that in high income country, we have a few of these 7 countries here. It's only telling us that among the high income countries, these 7 countries are the major producers of plastic waste. They produce a lot of plastic waste. Fortunately, Canada is not part of the list here, which is very good. But this can USA, Germany, UK, Japan, and Korea up to France, these 7 countries generate a lot of plastic waste. Now we'll move to upper middle income countries. We classify high income countries, upper middle income countries. We also have lower middle income countries as well as low income countries. And all the countries that you see here from the World Bank, these are the countries that generate a lot of plastic waste in each income archetypes. So we have 8 archetypes. So high income country is split into 2, urban and rural. So after doing all this to account for geographical differences, then we also divided plastic into types. So we have plastic categories. So we have rigid monomaterials, which we have still water, something like water bottles are rigid monomaterials. They are easily be recycled. This particular rigid monomaterials, you can have a look of them from foods grade bottles and etc. So we also have flexible monomaterials. They are very notoriously hard to recycle, like grocery bags, shopping bags, etc., trash bags, wrappers, etc. So we have multi-layer, multi-layer plastic. They are very complex. We have very complex composition. You can even think of some of the nose marks we have as a result of this COVID. They fall under multi-layer plastic, and sachet cigarette bags are all under multi-layer because they are very complex composition. Good. So now we'll now go into scenarios and model output, how the whole research was done, after giving the background of the system map and how we divided the whole world into income groups, and also as well as the plastic into 3 segments of plastic. That's rigid plastic, flexible monomaterial plastic, and multi-layer plastic. So we now we made some assumptions to model this plastic flow into the system. So we have our usually business as usual, that is if nothing is done, looking at the current growth of plastic waste in the system, what happens. And we have 5 key areas that we think that those are the interventions that will be able to mitigate plastic flow into the system. So the 5 areas are, we have reduce, that is reduction of plastic waste or plastic usage, of course, is one of them. And substitute, we substitute with alternative materials like paper, compostable materials, etc. We also have recycle of product through mechanical closed loop, mechanical open loop, etc. We have disposal or what we call collect and dispose, or collection and disposal. Good. So these are the areas that we think that we built our scenarios around and we did the modeling. So first, let's go to business as usual. So under our business as usual scenario, we have seen that plastic pollution is projected to grow from 11 million metric tons to nearly 29 metric tons, 29 million metric tons per year by 2040. So this is a very huge growth of plastic if nothing is done at all. This is how plastic is going to grow within this range. I've already said that plastic, according to previous research, is from 8 million metric tons to 12 million metric tons. So we had 11 metric tons. So if nothing is done, business as usual, then this is how plastic is going to leak into the system. Almost threefold, from 11 to 29 million metric tons by the year 2040. That's about 20 years from now. So what do we do? So plastic waste is projected to double over the next 20 years, as I've said. And let's look at, because we model this into high income countries and different income segments, or what we call the archetypes. So first, let's look at the archetypes that are contributing so much into plastic pollution. As you can see the figure, you can see that high income countries relatively, well, it's not so much as far as plastic waste projected to double, but the problem is going to come from what? Upper middle income countries and lower middle income countries. That's where we are going to have the challenge. That is where we can see that very astronomical growth. And these are some of the countries that are going to contribute to that. We have China, India, Indonesia, etc. So 9 of these top growth markets are in what? High leakage architects. We could use the word high leakage architecture, like mostly US is not part of that, but US is generating a lot of waste. Waste is expected to grow more, but it's not among the high leakage architects. The high leakage architects are China, India, most countries in Asia. So after we have seen that, so now let's look at what is the impact, what are the impact of marine plastic pollution and our business as usual scenario. We have come across with a very huge quantification, and we have seen that plastic leakage is going to be 29 million metric tons per year. And out of these 29 metric tons, 3 million metric tons are going to come from microplastic, and 26 million tons is going to come from macroplastic. Yes, this analysis, we also did a separate system map for microplastic, but I have not shown it. And for more details, I think we'll be able to take a look at either from Pew and Systemic 2020, what we call Breaking the Plastic Wave report. You can see more details about that. So jobs. So it means that it's also going to cost government 670 billion in terms of waste management. And also it's not even good for, it's going to increase our carbon print. Billions, about 2.1 billion of greenhouse gases are going to be released, and virgin plastic production is going to increase to 400 million metric tons. So these are the potential impact of plastic business as usual. So what we did next is to look at current commitment. Globally, government and industries have made a lot of commitment to tackle marine plastic pollutions. So these are the commitment they have made. For example, we have trade restriction to reduce the export of plastic waste through the Basel Convention, about 3 million metric tons. So these are all the commitments we have made. So these commitments were also more quantified, at least 89 of these commitments, like ranging from government and industry. And governments want to include bans, fees, incentives, etc. But the industry's commitments are mostly meeting recycling targets. So all these things were quantified, 89 of these commitment were quantified into our current commitment scenario, what we call current commitment scenario. Of course, the commitments are very good, but when you look at all the commitments that have been made and legislation has been passed, means that yes, they are, and this commitment at national and regional level, not local level. So when you put all those together and you quantify them, you see that it only reduced 7% relative to business as usual by the year 2040. Those, which means that more effort is still needed to reduce, to increase our commitment to reduce plastic pollution. So next, we'll look at comparison, because I've said we have 5 key areas that we'll look at. So let's look at the comparison of annual leakage rate under 5 scenarios. Note that the dot represents the current commitment. This black dot represents current commitment. So we have business as usual, we have collect and dispose, we have recycling, we have reduce and substitute, as well as system change. So all these things is a system change that promises a very good chance of mitigating marine plastic pollution. At least what is telling us that, but the system change is a suite of what solutions that will put together all these solutions. So no single solution will be able to mitigate plastic pollution, either using upstream approach or downstream approach, like reduce and substitute, which is upstream approach, or pre-consumption approach, will not be able to mitigate plastic very well. Or downstream approach, like post-consumption approach, like recycling activities, collection. Of course, they are very good, but it's going to, the cost is so much. So it is our system change, which is the last bar you can see here, that is quite promising. So let's look at a suite of system change solutions are likely to mitigate marine plastic pollution. And these are some of them. First, designing product and packaging more efficiently for recycling, expanding waste collection in global south. These are some of them. Reducing plastic waste export by 90%. So these are a suite of system change intervention that can reduce plastic levels at least up to 5 million. metric tons by 2040. Because if you look at business as usual, from 11 million to 29 million by 2040, so the system change is promising to reduce plastic leakage by 5 million. You can see plastic leakage is going to reduce by 5 million by 2040. And it's also good for our carbon footprint. You see that 1.6 billion greenhouse gases emission are going to be reduced as compared to over 2.1. And it's also good for government. Government is going to make huge savings because under business as usual, we have 610 billion. So it's going to reduce to 600 billion for government in terms of waste collection, management, etc. So it's good for our climate. It's also good for jobs. Jobs are going to be created. At least we have 700,000 jobs are going to be created. And what it means that these are formal jobs, jobs that mostly in upper middle income countries and lower income countries, the jobs are going to be there. And of course, we can also put waste pickers as frontline workers. So this particular analysis is also aligned, is aligned with United Nations Sustainable Development Target or Sustainable Development Goals, which is set by 2030. So what we did is strongly aligned with that. So we have, in terms of job creation, we also have good health and well-being because of time. And we also have large collection of recycling and services, as well as better for society in terms of development of better plastic alternatives. And we also have a reduction of 11% in government spending for waste between 21 this year now up to 2040. And it also decoupled the economic growth from our plastic growth. And the last one is also reduces greenhouse gas emission, climate change issues. So it's very important. And also, of course, as far as we are oceans and fisheries, much concern about our oceans and our water, our fishes. So it reduces leakage of plastic into the ocean by 80%. This is a very promising area. Good. So what do we know now? So take home, what are the key things, the key message that we are going to take home? So we have seen that business as usual is so scary because from 11 million metric tons to 24 million metric tons. It tells us that business as usual is very scary, but inaction is more dangerous because studies have shown that there will be more plastic in the oceans than fish by 2050, according to World Economic Forum and Ellen MacArthur Foundation, of course, so we have to avoid that. And the system change scenario will deliver co-benefit in terms of climate change, in terms of health and jobs for millions of people worldwide. So this is a snapshot of what system change promises to do. And for more details about the breakdown and everything, you can take a look at from Pew and Systemic Publication 2020 report that is breaking the plastic wave. So we can see that 80% of leakage is going to be reduced by 2040. And we have about 7 billion global governments are going to save about $7 billion. 700,000 jobs are going to be created. 25% of greenhouse gases are going to be reduced. That's coming from plastic. So it's not one particular solution that will be able to reduce marine plastic pollution. So it's a suite of all these solutions. So we have reduce, substitute, design, and we have scale up collection. Of course, scale up collection is part of the system change. Double mechanical recycling, we also have, as well as what? Scale up chemical conversion, dispose appropriately, and reduce waste export, especially waste export is also a very serious issue. Because if this is not done, it may even lead to national countries to fight or conflict. We saw about 2019 how Philippines and US were involved with plastic export dispute. So this is something that reducing waste export by 90% is very good, especially to upper middle income countries and low income countries, because they lack the capacity to be able to manage this plastic very well. Good. So we have reduced maritime sources, etc. So this is what time will permit us. So thank you very much for your attention. So we have the next one is working for near ocean plastic pollution works for everyone and it works for you. Thanks very much for your attention. And these are the references that we have. So I'm now open for any question, and in case we have questions and other suggestions, you can put that across. Thank you so much.
Thank you, Ibrahim. It was really a good presentation. I really liked it. And personally, I have a question to start the Q&A. Most importantly, if anyone here have question, please post it on the chat box. My first question for you is a tricky question.
Good.
We know that most of the exploited species have a part of their distribution in the area beyond national jurisdiction regions. We also know that the accumulation of macroplastic and microplastic are really important in those regions because of the oceanographical currents. Have you heard any study that includes the effect of plastic from the area beyond national jurisdiction? And are you aware of any action of UN or wider group to do something in those regions in terms of plastic?
Yeah. Yes, you said it already. It's a tricky question, and this is what research is all about, to unravel tricky solutions to tricky questions. So as you said, I'm aware of a lot of commitment. As I've said already, commitment has been made by national levels and government to be able to mitigate some of this plastic flow. But as you said, plastic flowing is not only restricted to a particular geographical areas. Yeah, of course, it's flow here, but it gets into the system, it moves to a different area. The end point perhaps may be different to the pollution source. Good. So there's a lot of studies currently going on that we are looking at the impact of even climate change. We are looking at overfishing as well as pollution, and plastic is one of them. We are trying to use high resolution data to come out with solution to that problem. So I think currently it's an ongoing research, and that is what we are working on now. So very soon we're able to get very good answers to this particular question. So thank you very much. It's part of the research we are doing. Good.
Thank you, Ibrahim. I think Colette have a question for you.
Good.
Hi, Ibrahim. Thank you so much for that talk. It was super interesting to get to know your work a little bit more, and I really like the way you presented it. I was going to ask you, I'm always interested in this because your research is so applied, right? You like develop this model, and you look at how what difference governments basically can make based on their policies. So I was just wondering whether you have had any engagement with different governments, or how they have reacted to your report by saying, great, now we have like specific measures that we can take, or now they're really scared because they're like, oh my goodness, you're telling me what to do and I have no idea how I can do it. I'm just wondering whether you had some sort of involvement with with policymakers or governments in terms of actually taking the step to following suit with what your recommendations are.
Oh, Colette, that's a very good question. I'm so happy for the question, and it's very good. After this paper was published by Winnie and Lau and co, of course, which is about evaluating scenarios of marine plastic pollution, we did a lot of corporate engagement. We had YouTube. You go to YouTube, you have Breaking Plastic Wave. We invited a lot of industry experts, and they were part of it, and just to tell them across that, yes, this is the problem we have seen, and we all know it, and this is the kind of analysis we have done. And this system change involves a lot of corporate engagement. No one single solution will be able to solve that problem. So there's a lot of engagement going on. Myself, I attended a lot of this online YouTube interaction with corporate leaders, and we try to put across, this is what we have done, and this is what we can do to mitigate the inflow of plastic into the ocean. So it's ongoing. And Winnie, of course, the co-leader of this particular research from Pew, she has a lot of work going on involving corporate leaders, government across the world. So I think, and these publications have been translated, especially into almost about 3 or 4 different languages, so that people be able to understand current status of the research, and how we'll be able to put our effort together to mitigate the oceans. So this is how far we have reached with corporate engagement. Thanks.
That's great to hear.
Can I add a little bit, Colette?
Yeah, of course. I mean, you have to ask Ibrahim, but yeah, for me, it's fine. But yeah, no, thank you, Ibrahim, for that clarification. Otherwise, that was really great to hear that you followed up like that.
Thank you. I appreciate that.
Yeah, just to add a little bit about the implications of the work so far, Ibrahim has covered that, and Winnie is doing a lot of that. And actually, this is the paper that made me to kind of do a tag team with the Minister of the Environment of Canada when they declared the ban on I think 6 different single-use plastics. So we're in the news on the radio and talked about this, and it has also led to my invitation to join the National Academy of Sciences committee to look at the contribution of US to plastic production, consumption, and pollution into the ocean in order to, and that was actually sponsored by NOAA so that they will get policy actions to take to Congress. So there's a lot going on here in terms of practical application. Thanks.
I think there is a question from Andres. Andres, do you want to ask your question? Okay, I will read it. Oh, he cannot unmute himself. Okay, so I'm reading the question. Personal action are great for reducing plastic pollution, but the scale of the problem that Ibrahim showed likely will need way more effort. I want to see if Ibrahim has already thought of specific policy action that are needed at a systemic level.
Good. Yes, at a system level with specific policies. We said earlier on that no single solution will be able to solve this problem, either upstream solution or downstream solution, but a system of like a suite of system change intervention is required. So what we are doing is that, yes, the specific policies are corporate engagement. This is a very important area because, and also government to make more commitment, because the commitment so far we have seen they have made only reduce about 7%. So more commitment is needed. And all those commitments all combined together with corporate engagement, trying to get industry leaders to make sure that at least whatever plastic they produce, they should have recycling in mind or a way of managing the plastic waste in the system. Initially, I said in an ideal situation, any plastic that is produced should be able to well manage, but we don't have that in now. So imagine we are able to engage corporate leaders and they all are committed to meeting their recycling target. Unfortunately, COVID has come to introduce more plastic into the system. So by yet, we haven't given up. We still make sure that there's a strong corporate engagement because most of the plastic is coming from corporation because they produce a lot of them. So there's a lot of corporate engagement led by Winnie and co-industrial level to mitigate the plastic, at least to reduce the amount of plastic that they are producing. And whatever they produce, they should have what? Recycle or a nice scheme to manage plastic in place. So at least to minimize the impact or the spillage into the environment. Yeah. So corporate engagement is one of the policies, the policies that we're embarking on with designing for recycling in mind and reduction as well. Good.
And in addition to corporate, we also have NGO action. You know, Oceana is taking this thing up seriously. In December, they actually went head-to-head with Amazon. They took them on because it's one of the big sources and now the Amazon is now talking with Oceana on how can they reduce the amount of plastic they put into the world. So there is NGO action, and you have, you know, NGOs are like all of us. Some of them are really hot, and some of them kind of try to convince people. Some of them jump on the top of the roof to get action. So it's a combination of everything, okay? Yeah.
There is a last question. It's clear that resolving this problem will require an international cooperation. How do you suggest that could be achieved?
Yeah, of course, we have to be optimistic that we'll solve, there will be cooperation. That is the first thing that we all have to be thinking about. So with serious international cooperation, this is a global map, and we have also shown that plastic pollution is not restricted to a particular geographical area or particular area. It's global. So, and so it provides a lot of co-benefit. Of course, in terms of climate change, we are all struggling with it now. We are all looking at the implications, how the world is struggling with it. So, of course, it will inure to our benefit globally if all global cooperation all put hands on decks and come together to solve this plastic problem. We are very optimistic. That is why there's a lot of engagement at corporate level as well as the government level to be able to mitigate this. So I'm 100% sure that there'll be a lot of government support looking at the scale of the problem and the potential solutions that we are all going to benefit, because working for zero plastic in our oceans, it works for everybody. It ensures the benefit of the whole globe, not for every one particular area. So at least it is our best interest, all of us as a global body, to come together to solve this particular problem. So I'm sure we'll get global cooperation for this particular solution.
Thank you so much, Ibrahim, for this great presentation.